Good afternoon and welcome to the Utilise Technology for Enhanced Lean Manufacturing Results webinar hosted by Cimlogic. My name is Olivia Thornton, I'm the marketing assistant here, and I'm joined by Keith Findlay, our resident Lean expert. Okay, so just a bit of housekeeping. We'll have time for questions at the end. If you want to submit a question, use the question window in your GoToWebinar control panel. We will have time at the end to answer as many as possible, and for a copy of the presentation or for further information you can send an email to inquiries@cimlogic.co.uk. Just a quick bit about who we are and what we do. We were established in 1997, but we're currently based in Saltaire in West Yorkshire. We are the leading global partner for Parsec's automation, leading MOM and MES solution Traxis. Our current goal is to deliver outstanding manufacturing solutions which enable our customers to continue to be world-class performers. And a little bit about Keith Findlay. He is our resident Lean expert, Lean Six Sigma black belt with 15 plus years experience in Lean programs. Over the past 15 years he's worked in the automotive industry implementing Lean manufacturing principles, changing their working practices from mass production to Lean production, with the results being best in class for the global company. From there he moved on to medical devices to reduce waste and improve yields, then on into food and beverages to implement foundations of Lean in one of Britain's largest own branded manufacturers of soft drinks. Over to you, Keith.
Thank you very much, Olivia, for that introduction, and welcome all to this webinar on utilising technology for enhanced Lean manufacturing results. I would like to spend a brief period of time to talk about the strategic objectives that are driving manufacturers to implement and proceed with initiatives and programme, and then from there we'll take a look at what typically is implemented during such programmes and where it fits into your environment. So, a little bit about the background. So while Lean manufacturing has been in vogue now for some 40 years, it continues to grow in importance, and especially as new requirements and I suppose competitive pressure surface in the manufacturing arena. So in the early years of Lean initiatives, companies made progress fixing shop floor and human-centric issues, probably without ever touching IT systems. Well, how does that look like today? Well, in a world of globally distributed manufacturing organisations, rapidly escalating energy costs and diverse supply chain networks, the business landscape has radically changed, and with these changes, manufacturers must now recognise that software has become virtually a requirement for successful Lean manufacturing. This webinar will look into the role a manufacturing operations management system, or MOM as we're going to probably know it as we go through, can perform, complementing and supporting the need to drive waste out of operational processes. And the integration of software into a Lean programme has been identified and validated as a best practice enabler across a framework for change management and continuous improvement. And it's not surprising, an overwhelming majority of the top performing manufacturers use an MOM system to support their Lean initiatives by implementing best practices, measuring performances and improving the process to continue the cycle of removing waste from operational processes. So let's take a look at the history. So this illustration here shows you the beginning of time when Henry Ford began his moving assembly lines, right through to Toyota picking that industry up, and looking back at Henry Ford's his ingenuity there. Obviously Toyota coupled that along with Taylor, who was the inventor of the modern management techniques and industrial engineering, and then again Deming, who was, I suppose, the father of modern quality management. And they were looked at to see how they could improve their productivity and increase their quality to achieve the worldwide ranking within the global automotive market. This was obviously driven through the need to make change and base their world on where there was no money. It was post-war, and they needed to rebuild the country and then do so without the need for a lot of money, so they had to make things more effective and efficient. Well, the great news is that it worked. The Japanese productivity and quality surpassed that of the North American plants, and it caused the Americans to try and run around and scramble to kind of remedy the situation. Womack, with his International Motor Vehicle Program at the MIT, they also identified the key differences between Toyota's TPS, the Europeans' Auto industry and the North Americans traditional systems, and then they eventually coined the phrase lean manufacturing, and this was more to encourage the adoption of the TPS methods. This term has since been expanded into lean thinking, and this encompasses the improving productivity within the service organisations. As time has went on, more and more people adopt it, and even Ford, who sort of initiated this back in the early 1900s, when almost near the turn of the century, had to revisit their whole environment and look at how they managed lean and how they took the Toyota system and pushed forward. So it's quite an interesting cycle of events where the originators soon became behind the eight ball a little bit, and they were then the followers through things. And people still look to the automotive industry to understand and enhance their own methods and techniques. Last week, I think it was, I attended a Shingo Institute webinar, and they used this illustration that I've got on the screen just now. And it's an example of where the different people are within the industries, where they're at with implementation. And I thought it was quite an interesting slide. The main topic they discussed, which reflected my own findings, was that people often struggled to maintain momentum and keep the wheels turning. And this was usually felt after the initial implementation phase, or what I typically call the honeymoon period. And until recently, most of the foundations of the lean movement were based on manufacturing and process improvements from the 70s, a time when automation and software applications were probably quite early in their years. Fortunately, the past 20 years has witnessed tremendous leaps and advancements within these disciplines. And again, however, until recently, I suppose the thought of using software to support lean projects was probably not really heard of too much and didn't really have a place within the collective lean circles. This illustration here shows a little bit more than perhaps what this slide describes. It goes into culture and the behaviours, and it encompasses the things that you need to have. You're looking at your systems, you're looking at the tools. So it's one thing to have one part of it, you need to have it coupled up with a system. And that's not to say an electronic system, but a group of things that go together to make it work for you. When we talk about operational technology, we talk about the interaction between the actual shop floor. So you're looking at maybe some conveyor systems or some packing machines or some fillers or just even maybe standalone things that like weld robots and so on and such like. And a recent survey of manufacturers conducted by the industry analyst firm ARC found the adoption of lean manufacturing increased by twofold over a recent 15-month period. And around the same period of time, research on the adoption of manufacturing operations management systems, or MOM as we spoke about, has also shown a steep incline with a growth rate of approximately 27%. That's a reasonable growth by any stretch of the imagination. And based on these trends, ARC set out to identify what the best practices were amongst the leaders for lean manufacturing when they were looking at adopting and implementing systems. That study theorised that today's complex, dynamic and global manufacturing supply chains and manufacturing software solutions such as MOM can play an essential role in the success of lean manufacturing efforts. The study actually also reports that industry leaders have improved their right first time, rolled throughput yield, inventory pipeline, on-time delivery, scrap and rework, and overall equipment effectiveness. And these are all fairly standard metrics used to gauge overall success. The report then goes on to, more in depth as to the various behaviours used to attain these results, and ARC defined leading leaders as having established best practice across 4 main parameters, and these 4 are people, processes, technology, that's the key thing here that we're talking about today, and metrics. I suppose more importantly, the report identified the sole defining characteristic leaders share that manifests these best practices. Leaders successfully use the technology to support their continuous improvement program, with Lean and Six Sigma typically among the main programs specified. And again, 77% of those surveyed reported that the use of their MOM accelerated their continuous improvement program. The balance of this particular webinar will discuss in further detail how Lean leaders leverage MOM to support and enhance their initiatives. So, we spoke about MOM. What is it then? Well, simply it's an abbreviation. It just means Manufacturing Operations Management Systems, which refers to a computer system that manages plant production. Nothing more so than that. It's often a system that's used to integrate shop floor operations with enterprise resource planning applications like SAP or WMS systems and so on and such like. And as you can see from this illustration, it's got further connectivity. So you can go from your factory floor where you have PLCs and SCADA interactivity. You've also got your office-based environment, maybe that looks and catalogues the data that's happening on the shop floor, maybe some laboratories. But also it can encompass, especially in today's world, where you can actually bolt on the likes of applications through mobile phone or handheld tablets, and then certainly laptops are now more transportable and they're more robust, and they can take a bit of a shop floor beating, shall we say. Now, this approach encompasses a broader set of functionalities beyond just production. It also includes quality, warehouse, maintenance and labour operations, and again across multiple locations. And one of the key successes in deploying and sustaining Lean can be found in the manufacturer's ease and ability to actually change a process. One thing to remember is a static process can't support the implementation of new best practices to remove waste as part of a Lean program. Processes are implemented at one plant but not across multiple departments and geographical locations will at best have limited benefit in reducing waste across the organisation. Now, a remark made by Paul Swift from beyondlean.com was, in quotes, "Despite attempts, most businesses have not been able to capture or sustain the benefits of Lean transformation." And this is in his introduction to his step-by-step Lean guide. Further than that, Lean manufacturing represents a fundamental change, and most businesses have pursued change in tactical rather than strategic manner. The methodology of many companies is to rely on a series of quick-hit approaches that deliver short-term benefits but aren't sustainable in the longer term. And add this to the reluctance of many companies to consider the business as a whole rather than concentrating on operations or manufacturing, and you have a recipe for failure. In other words, the challenge to overcome is not what processes should be changed, but which processes can be changed, and more importantly, stay changed. When evaluating possible process improvements, it's actually quite easy to write them down on a whiteboard and achieve agreement to implement, and with some effort it's often possible to initially run these process improvements manually, maybe testing the new process and evaluating if benefits can be achieved, at least in the short term. The challenge is actually getting people to embrace and adopt the change after the Lean implementation project manager or the external consultant has left. After the Lean project focus has passed, after this, add to this the challenge of manual process, and it's easy to see why, I suppose, many of these Lean initiatives fail. Try to implement this process across different locations, then the complexity and challenges increase exponentially. And a change in process impacting many plants beyond the visibility of a plant manager's daily routine might never stick, especially if the responsible party for the success can't see that the process is not being permanently implemented, and it quickly becomes obvious that the manual process improvements don't work effectively, even more so when implemented across a global operations environment. I think the solution is to automate the process, the improvement, remove the friction of human reluctance to change, and if the complexity or the programming or other skill required to change a business process is difficult, then the thing to change is the process management system. Now often, this process may involve multiple systems, maybe equipment vendor user interfaces, or even complex XML or other web-based programming. And again, alternative manufacturers who embrace the need for change recognise that the investment in a business process management system can pay a handsome reward. And it's capable of supporting frequent changes or updates. And this system must be easy to use, otherwise it offers no benefit over existing static systems. Without the need for complicated programming by somebody outside, like a consultant, somebody from IT or an IT firm perhaps. And it's not always available at a moment's notice. A winning approach to Lean is one that spans all dimensions of the manufacturing enterprise, encompassing the entire value stream from ordering through manufacturing to cash received. MOM systems touch every area where the Lean program might impact on operational processes, so therefore have the capability of being an ideal solution. But the MOM system must be capable of easily supporting process changes and execution while still automating lean process improvements. Leaders select manufacturing operation management systems that span the entire suite of operational processes, amplifying the potential benefits of such a program. The ability to infuse an organisation with embedded automated processes enables MOMs to address one of the most challenging aspects of manufacturing operation management and lean. It's the enforcement and continued adherence to defined processes. So you imagine you've got a system there that's sitting live on the manufacturing environment, and you need somebody to do something. When an event happens, it could be a changeover, it can trigger a pop-up on perhaps an HMI screen or some sort of user interface to go and carry out a particular task. And this task may be the new thing that you're looking to implement. So therefore the guy sees it, it pops up on screen, he now has to take an action, and off he goes and does what that task happens to be. To complete that task, he accepts it, acknowledges it, maybe puts some comments into it, and then it saves itself somewhere along the line, and you see the result of that as the lean leader. You can then make reports based on that person's activity, and you can show directly the correlation of that activity to improvements within the manufacturing process. So you've now got some real-time data based on the operator interface and a task being completed and improvements being made based upon that task. Manufacturing operation management systems utilising an effective business management process framework best support the implementation of new lean processes, and it's providing control and monitoring of existing and new processes to ensure timely execution and conformance. And we'll talk about conformance later on when we talk about quality systems. Again, phrased differently, while lean techniques provide the methodology to optimise business processes, MOM systems provide a highly competent systems infrastructure or implement lean efficiencies, sustaining them on an ongoing basis. Leveraging IT systems with embedded business processes ensures operational consistency across multiple functions and locations for actions performed by personnel, equipment and facilities. And again, if you'll take a look at this graph here, so let's at this image here. So you've got a bit of analysis there, you've identified what you're going to do, you implement the change, and you've got an increase in performance based on this new feel-good factor about what it is you're doing. You've got people engaged, you've got them motivated, everybody's doing what they want to do because they get excited about it. Now if we follow the red line, and this is what typically happens, not necessarily everywhere, but sometimes when the organisation is quite large and it takes a lot of time to get around the different various people, the manual process can taper off once that initial honeymoon period has gone, as I mentioned earlier on, and you start to see a decline in what you've tried to implement. If you use technology, operational technology or an MOM system to enhance that, it stays live because the MOM system is automatic. It just does it all the time. It keeps moving and keeps moving, and it keeps bringing up the pop-ups. It keeps bringing up the things that tell people to do things, reminds them, puts a flashing light on, whatever your technology happens to be. And as you can see, as time goes on, the process is improved and improved and improved because it becomes more habitual for the operators and the managers of those operators to carry out tasks and to ensure tasks are completed and to monitor what they're doing and react effectively and live to the changing in the situation. Reduced variation is obviously a key aspect to continuous improvement programs. What we need to do when you embed a process, especially an IT process, and compare it to the manual execution of the same task, you can see a variance there. So if you've got the ability to introduce an IT-based process and match it with a manual-based process, perhaps part of a pilot scheme, you can see the variance, and that there gives you the opportunity to put strength into the argument that technology will enhance your growth within your lean implementation. Obviously streamlining the process of instituting change and refinement lets manufacturers achieve greater success, and the more improvements can be implemented rather than merely theorised, again helping drive an efficient, successful lean program. There's no longer an acceptance of ad hoc business processes. Processes are deliberately planned and standardised to reduce waste save money and create quality products and services, and processes are immediately consistently implemented, and more importantly, these processes are sustained over time. Back in the 70s, the concept of global was much different than it is today. Packaging a product and shipping it for sale in Europe was global in the 70s. Today it requires sophisticated product differentiation, new packaging and adherence to localized regulations. And in search for lower cost, faster times to market, heightened product innovation and local market acceptance, manufacturers set up operations overseas, adopting global outsourcing strategies. However, integrating operations from plant to plant across borders can actually be quite tricky. And aside from the obvious language and localization issues, global manufacturing adds an exponential layer of complexity and the need to navigate and adapt to ever-changing global market dynamics. Today's emphasis on global sourcing, distribution, distributed production and just-in-time production that is synchronized to be in sequence with supplier shipments is pushing manufacturing to a whole new level of lean. And for companies that have operations spread far and wide, optimal performance requires frequent adjustment and relocations of operational capacity. And as markets and supply sources shift, manufacturing operations that are lean shift more readily. We were asked to have a look at how the capacity in one plant can be transferred to the capacity of another plant when the market changes, when there's a need for a different volume of products to be manufactured or distributed globally. And what they were looking for was that they wanted to be able to, from a global perspective, look at what each plant was doing across the world. And one plant was in the Middle East, another plant was in South America. But they wanted to look at and they both made the same product. That was the key thing here. And they wanted to look at what was doing what and when, so that they could, when they're scheduling, which came from a central location in Europe, they could actually decide which plant was going to make which product and when it was going to be done. And the only way they could do this is by having that visibility within their own manufacturing organisation, and then you could become more efficient. Transportation costs were reduced. Plants' efficiencies went up because there was less need for changeovers and so on and such like, and it could be optimised so that they could produce what they wanted to produce at the time they needed to produce it. If you imagine trying to do that through the old world, where it was fax machines and telephone calls and perhaps maybe snail mail, for the want of a term, it would never have happened with the same frequency or the dynamic that it happens to be able to be capable of today. So I suppose in today's global economy, lean leaders understand it's short-sighted to consider a lean program within the silo of a single location, and waste must be removed from as many processes as possible. These processes now extend across supply chains, throughout operations, as well as into distribution production sites across the world. And again, if you want to be really far-fetching, visionary lead organisations think outside the box, extending and integrating processes to drive lean practices enterprise-wide across operations, sales, engineering, product development, procurement, customer services and human resources, all across the globe. Manufacturing operations management systems play a critical role when implementing lean across a distributed globe enterprise by facilitating and streamlining information flows amongst plants, suppliers, distribution centres and customers, and it can provide a system to identify and capture and replicate best practice across the enterprise, with support by diverse manufacturing methodologies, geographies, cultures and markets, enabling implementation of continuous improvement programs. And this information flow across the globe can enable companies to address the strategic imperatives like governance, risk management and compliance as they optimise business processes. And again, another comment that was made, traditional compliance and lean initiatives have actually been at odds with each other because of the heavy burden of compliance. And this was made by Mark Orbach, who's the editor-in-chief of trade magazine Pharmaceutical Processing. And he mentioned this in a webinar he hosted on lean. Manufacturing, gaining efficiencies and maintaining compliance on the plant floor, but with IT solutions, the way they're designed with the ability to automate much of that workflow, you can now take the burden out of the shop floor and automate it as part of your process, thereby giving you the assurance that you're not only meeting compliance, but that compliance is now part of your workflow. So we can have a look at where technology has been introduced or where it can be introduced into your own world. So Kanban cards are a typical standard component of a traditional lean program. It's just a simple signalling system that basically uses a card of some sort, and it allows the movement of materials within the manufacturing and production area. It signals the movement of materials from maybe outside, from a supplier to the production facility. And again, traditional based Kanban programs typically operate within a single facility, so the use of an on-site ordering queue makes perfect sense. However, distribute your operations across several locations, coupled with the use of third-party outsourcing vendors and the use of paper-based Kanban systems starts to fall short. Now, once again, the implementation of an MOM system can quite effectively address these shortcomings, providing an e-Kanban signal when inventory levels should be restocked or when a production process is ready for the next raw material. An advanced IT system can be integrated across all the areas of operations, from production to warehouse to quality assurance, ensuring idle inventory levels are minimised or even eliminated, yet adding more functionality to an integrated MOM system. One of the key things here is that if you have a card-based system, then you have to think about the management of that. And based on my experience within the automotive world in the early days, we would use a card and there may be, say, a dozen cards per part. And when you think about a car, for example, may have about 2,500 parts on it. That's quite a lot of different individual cards. And any of those could get lost at any given time, which would result in a stock shortage. These cards, when they move things around to become more efficient, have to then be reprinted. That is actually quite an extensive cost when you think about it. I remember doing one re-smarting of the system, and it came to about £8,000 just on the card itself. Nothing else, not the labour associated with it, not on the moving the parts, not on the reordering of the marketplaces, but the actual cards just themselves came to about £8,000. Now when you look at that compared to an electronic system, to change it, well, nothing changes. Your signals are already there, your buttons are there, or whatever way you trigger it, it's already there. It's somebody sitting on a PC and then reprogramming it. Granted, the actual infrastructure itself is maybe a little bit more costly on the outset, but you'll actually get that money back through a reasonable return of investment based on the effort that's required to actually go out and take all these cards back in, as opposed to somebody programming some buttons and updating an electronic system. And again, when you've got an electronic system and you have it placed in one, perhaps area, one manufacturing site, and you want to then move it elsewhere, you can literally just lift it and drop it with little interaction or little connectivity and maybe a small amount of configuration. You've already got what it is you need to do. And again, you can take your same MOM system and start measuring your performance improvement. So you don't have to be a lean guru to know what some sort of tracking and reporting system is necessary to help identify where the best practice might exist, as well as what quantitative benefits might be obtained from implementing a process change. And performing quantitative measurements on an operational performance can be an excellent way to locate future performance improvements. A comprehensive reporting system can be established to summarise operational results and highlight areas for improvement, such as comparing one plant's performance to another or to the entire industry average. I don't think you can walk into anyone nowadays without KPIs being up on the wall somewhere. It's part of most people's CVs. When anybody goes for a job interview, the word KPI comes up. So I think it's well embedded into today's environment and the industry. If you can see what your performance is real time, live, you can then, and if it starts to go into the negative, you can respond to that effectively. When you'll use an MOM system to actually track your performance, and where you have maybe some data that's pushing you towards a negative point, you can actually put a comment there. It's live. You can see you've made a change, and then you can see that change moving you back towards where you should be going. You're back on target. And you've got correlation then from the trend going into the negative, an action taking place, and the performance going back on track to where it should be sustained. And once again, a well-conceived and implemented MOM system can accomplish this task, providing a platform for consistent performance measurements, tracking the operational statistics most relevant to you achieving your highest possible performance. As was true of implementing new global best practice processes, a global system for measuring key performance indicators can amplify visibility to enterprise operations performance, quickly highlighting those business processes not delivering the desired result, as well as those setting a new standard for operational excellence. As I mentioned earlier on, we were speaking about quality. I'm going to talk a little bit more about it here as well. So traditionally, quality management applications were implemented separately from ERPs and MOMs, but today's manufacturers have adopted a more holistic approach that considers quality as an integral element of core business processes as opposed to versus a bolt-on strategy. And management of quality control in a lean manufacturing system is critical. In a lean environment, the management of quality control shifts from an inspection-orientated approach to defect prevention, and this means the inspection at every phase of the production process, from material purchase, delivery, inventory and supplying to processor, as opposed to the conventional inspection process conducted at the beginning, maybe the during, and maybe at the end of the process. If you imagine you've got a live manufacturing process and you can actually measure the quality at every stage within that there, you can stop the defect immediately. You're not actually waiting to catch it, you've caught it. You're being very proactive. And again, if you couple this with a management and operational management system, you can actually enter that data live into the system. And if it's clever enough and you've got the appetite to make it enhanced, the decisions that the system can make on your behalf based on the measurements that you're giving it. So it could be the fact that a bottle of juice doesn't have enough carbonation, or it could be the fact that paper doesn't have the right thickness, or it could be that there's not enough pressure within a can of some description, or it hasn't been cooked long enough, perhaps if it's food. Something has to happen then, something has to change. The system itself, once it gets this information, whether it's electronically or automatically captured through sensors and cameras and weigh scales, so on and such like, or whether it's manually entered, the system can flag up and go, hold on a second, something's not correct here, something needs to happen. You need to do, as an operator, need to tell somebody that something's not working, and we need to get this fixed. And straight away you can make a difference to your whole manufacturing environment. You've got real-time data. This can get flagged up into the engineer's workshop. They can come out with the correct tools and do something about it right there and then. And a remark is made on the system at that point. Something went out of control, we fixed the out of control, we're back in control, we're moving on. Then if you have external people coming in to have a look at your systems to perhaps audit you, and I'll always audit the quality function first, I'll look at what you do to make sure you stay compliant. And this is one of the great areas that you can actually utilize an MOM system to show that compliance and show them that your reaction to an incident is thought out and fruitful, because the performance has been improved since, or at least at the very worst it's been back on track. And again, in order to best support quality control, data collection, reporting processes, you need to identify a starting point for the improvement and track progress as processes are refined. And many companies conduct data collection reporting manually in offline systems, typically Excel, which generates waste in terms of time and effort, and also introduces an opportunity for error. I spoke about ARC. They actually mentioned about in their report that leaders empower their people with access to real-time data to improve decision making and their ability to evaluate changes identified through their lean methodologies. And for example, nearly 50% of leaders leverage MOM systems to calculate metrics related to right first time. A high RFT metric measures an organisation's success at removing manufacturing waste and defects, or the ability to get it right first time. Manufacturing operations management systems offer employees, supervisors and plant management visual real-time dashboards focused on key performance indicators that can be used to monitor the whole operation, lines of business, functions or processes, with the ability to drill down on any data point for the detail. And these systems can also notify users immediately when out of control conditions occur. So process owners and process specialists can capture the root cause for corrective action or for best practice implementation. And this empowers the people who do the work with the right information to identify problems and take appropriate corrective action. Now, it doesn't stop there either. And again, over the last 20 years, there's been a growing pressure on businesses to pay more attention to the environment and resource consequences of the products and services that they offer. and the processes they deploy, and the rise in energy costs has now made this initiative mandatory. To achieve sustainable operations, conserving natural resource and reducing their environmental footprint, manufacturers are now looking to get more out of their lean programs to remove wasted energy use, improve quality, get it right first time, and defer capital expenditure and expansion by running operations more optimally. When you look at an MOM system and how it can track energy usage within your manufacturing site, it could be looking at the heat of some ovens, that shrink wrap cases. It could be looking at the length of time lights have been left on in an unmanned area. It could be looking at when heating is used and optimising that, so on and such like, and you have a dashboard that can capture all this. Nowadays technology is all connected and it's easily to get connected, so you can actually manage this effectively and put into place some rules, some parameters that allow things to be switched off or go into sleep mode quicker, to switch off conveyors when they're no longer required, all based on perhaps recipes or operational time and so on and such like. And sustainability goes beyond doing the right thing and being a good steward to the environment. It's also key to a competitive advantage, cost reduction and customer satisfaction. Again, manufacturers understand that the cost of materials and energy continues to increase. These costs become an even larger component of the total cost, and it's currently up to 70% or more depending on the industry, and then you must adopt effective sustainable strategies today. Implementing lean manufacturing is one way that manufacturers can enable sustainability across the various business processes, and the focus of improvement programs can be expanded to include and embrace sustainability themes, including the adoption of application of lean tools and techniques or to sustainable improvement projects. Lean manufacturing can help identify overall requirements and align need for capacity, thus ensuring product lines are optimised, energy is maximised and raw products is fully utilised. And again, there is evidence between recognised the link between lean and green. The Society of Manufacturing Engineers recently established the Lean to Green Sustainability Tech Group, and this group helps members face the challenges of sustainable future for global manufacturing. And it uses the lessons of Lean to advance learning and innovation across the industry using Lean principles such as continuous improvement. Society of Manufacturing Engineers says that companies can identify what is valuable, eliminate waste and embed learning cycles that can be used every day. I suppose the emphasis on sustainability contributes to Lean improving overall organisational performance and efficiency, where there does exist synergistic relationships between Lean and Green programs in general. In particular, sustainability efforts focused on waste elimination offers significant benefits to Lean manufacturing. Sustainability programs tend to be enterprise-wide. The impacting processes spread throughout the enterprise. Therefore, when selecting an MOM system, criticality of supporting for implementing and upgrading global best practice should be placed at the highest importance. And lastly, as the green improvement is still in its early years, best practices for sustainability operations are still in a state of change. As a consequence, be sure that if you do implement an MOM, this enables rapid process change to keep up with the sea of change currently underway within the sustainability or green movement that's currently underway. So today, MOM is now recognised as an essential component of lean manufacturing. In today's world of complex global supply chains, ever-changing product mix and greater demand volatility, yielding the benefits of continuous improvement reduces waste, improved response times as well as sustained initiatives. Manufacturing operations management has been adopted by leaders in lean, integrating the need for the real-time plant environment with the transactional environment of business systems. And again, MOM systems support the application of lean best practices while adding value to lean initiatives. It encompasses processes that span across multiple areas of operations by efficiently establishing and maintaining business processes, I suppose ideally through a framework of business process management and the collection of operational data through production, the supply chain, the warehousing, the execution of maintenance management programs, more cost-effective continuous improvement as possible, saving time and resources to further maintain and optimise operations performance within the business. Right, that's all I have to say in relation to utilising technology, although if you want more information on any aspect of this webinar, then please email me at the address which will be shown shortly. I've also started to publish a 12-part series of blogs on the difficulties that face Lean implementers and how to overcome them. The first one's actually already out there. Olivia will provide the link shortly. So thank you very much for listening. Olivia, back to you.
Okay, thanks for that, Keith. Thanks for the talk on utilising technology to enhance lean manufacturing results. I'd like to ask some of the questions that have been raised during this webinar, and I think we'll start with Robin Cliff from Jaguar Land Rover. He says, this may be controversial, but how does adding technology help in our company's environmental policy of reducing energy?
Good question. I'm guessing from you're coming from an environmental background, so you'd be looking at why is putting more computers and screens and all of this technology going to be beneficial to me? Sure, it's going to use an awful lot more electricity and so on and such like, and you've got a valid point there. I suppose the pushback to that would be that when you have everything connected, when you can see where all your lights are switched on, where all your air conditioning units are being left on, printers perhaps and monitors for PCs, so on and such like, and that's just in the office environment. To take that to the shop floor, you may have conveyors that are running idle because that part of the operation is not running any longer. You may have ovens that you use to warm up parts that have been left on or not certainly going into sleep mode. Perhaps there's power going to some robots in the weld shop and things like that are consuming electricity when realistically they could be powered down completely, especially when you've got non-manufacturing periods like so weekends or through the night or during break times or changeovers. So if you introduce technology to that system, you can actually see on a dashboard where the consumption is being used and perhaps even where it should be being used, and you can do something about it. And again, if you think about the size of a manufacturing site, it can be quite extensive, and for somebody to have to physically walk around and touch all of these areas might be laborious and probably not get done because of that. Whereas if you have a dashboard that you've got interactivity with this technology, you could from a remote location decide to switch off the conveyors when you've got an idle part of the line or the air conditioning in an office that's already locked and you've got no access to, or even just simply switch the lights off on the operation floor when you're in the canteen, so on and such like. So these things here can happen that way, but you have to think about it from a global scale and think about where you can get the benefits, and right down to having better drive motors that push the hot air through a factory to give it the heating, and more efficient systems like that where maybe steam is controlled better when you're using that to heat water and so on and such like. I hope that answers that question. Have you any more?
Okay, next question from Carolina, Princess Soft Drinks, and she asks, how will an MOM system help me in reducing the waste generated from our manufacturing processes?
Okay, so soft drinks, so I've worked on that myself. So you go from, so scheduling will send down to the manufacturing side what they want to have made, what they want to bottle off. That system then can automatically order the raw materials in. So if you've got it set up in such a fashion that it triggers as soon as that production plan's been sent down, it can trigger the driver for that. It's like an e-Kanban system there. So stores can bring to you the ingredients, whatever it happens to be, the sugar, the acid, the flavours, all of the things that go into soft drinks, so that you're not having to request it, so the time's been, that efficiency's been made, but also that you're only putting onto the shop floor what you're actually going to use for the product that you're needing to make at this point. If you take that to the next point, you're only actually, when you're mixing this into the tanks and what have you, you're actually mixing the required amount. It's all measured, it's all metered. If you've got it connected to the weigh scales on the mixing tanks, you're only putting in the required volumes. You're not putting in a little bit extra, which obviously that's the free stuff, that's the giveaways, and that's a measurement that often soft drinks companies measure on. You then make the juice and you transfer it to the manufacturing line. So the manufacturing line could use an MOM system by looking at how much carbonation there is in the bottle, perhaps how sweet it is, or even better still, how much acid's in the no added sugar products, right down to scanning in the correct labels, caps, cases, shrink wrap, all of the things that are part of that as a package as a whole, that the quality department may check. And if you're all scanning it in the system, and again, and it's versed against the bill of materials that you'd have as part of your ERP, then you've reduced the amount of the likelihood of rework through the wrong colour of label or the wrong colour of tray or the wrong type of tray, even perhaps for a pallet. It's quite far-stretching. I've got quite a lot more information on that, so if you want more information, Colin, you can by all means drop us a line at the email about to be provided, and I can help you out with that.
Okay, I think we've got time for one more. This one's from Joe Nolan at Record Benkaiser. He says, I use Minitab and Excel to analyse all of my Six Sigma data. What could an MOM system do to improve the data collection so as to make the process more efficient and less laborious?
Okay. Okay, so this is, he's talking about Six Sigma there, something that's quite close to me as well. Typically Six Sigma, you'll create a sheet, like a data collection sheet, you'll print it off, you'll take it to the line, you'll ask the guys on the line to fill in some data based on what your sample size is, and that's okay. What can go wrong there? Well, when you need to have the bit of paper available at all times, it could get lost, it could get destroyed, it could get thrown in the bin, depends what the environment is, it could get wet, and then that's it, you've lost all of that effort. It may have to go through the night shift, which means you've got to, or the weekend, and you've got to try and keep hold of all of this information. That doesn't sound too much of a big task, to be honest with you, but it can cause problems if one sheet's lost and you don't have the ability to go back and trace what that information was, especially if you're doing a Six Sigma project and you're needing that data to do a proper analysis. So if you imagine being able to enter that data live into the system, so that when they take their samples of whatever the measurement is and they put that in, and again, you could actually set it up and it makes your gauge R&R a whole lot easier. Being from a Six Sigma background, you'll understand that you need that data to have a 95% confidence level that it's good data. If they do that live, there's no bits of paper getting lost. There's nothing going walkabout. You don't have to go to the shop floor to hand this bit of paper out. You go to the shop floor to instruct them on the screen. Now the screen can actually be set up to have a timer on it, so it pops up every hour or every half hour or whenever they change the product, the recipe, whatever it happens to be, and then the people who are responsible for that can enter in some data, and that could be based on whatever it is. It could be based on maybe a camera system taking some measurements or just some scales that weigh the product, whatever it happens to be that you're looking to measure. You then from that point can sit in your office and look at that data as it's happening and make decisions based on it, and it speeds up the whole process. There's no longer double entry. They're not writing on a piece of paper, then you having to type it in on a PC, and where errors can be introduced. And also, if you think further ahead, you can actually create that data entry as a trigger to allow the machine to work or not work. So for example, if they put in data that's beyond the parameters that's set, so the specifications, it's above and below the tolerance limits, it can send up a red light on, or it can stop the machine itself, or it can just put an alarm on or some description to say, these measurements, what you have entered are wrong, or these measurements that we have recorded won't allow me to make any more good product. So if you carry on, we will make waste, and that's a great point to stop the line. Do something about it, get the engineers involved, and then get them to fix it. And again, as I mentioned earlier on, you can put an entry in there to say we did this to stop this from being in the condition and bring it back onto track. And then you've got then evidence then that something happened and you did something about it, and the improvement was seen from there, and then your distribution of data is back to where it should be to measure your process effectively all the way through to conclusion. I hope that answers that question. If it doesn't, then by all means please email and I'll expand on that a little bit more.
Okay, thanks for answering those questions, Keith. That brings us to the end of this session today. For those of you who did raise questions that weren't answered in the time, these will be replied to by email later on, or if you'd like some further information, you can use the email address listed on the screen now, which is enquiries@cimlogic.co.uk. Please follow the link below to see the first in the 12-part series of blogs, or search LinkedIn Pulse articles on how to make Lean work for the rest of the series. You will also receive the exclusive free LEAN Whitepaper for joining us today, which this webinar is based on. You'll get those via email over the next couple of days. which just leaves me to say thank you for joining us, and we'll see you next time.